Calculus!
This is AP Calculus Lesson 7-5. Today's date is January 10th. Riley's sick, which means I have to be here taking care of him. Sorry again that this is the second time this week, but what are you going to do? Sick kids, right? So, speed and distance. Let's talk about what it means to go faster or slower. So let's analyze a few points on here. I'm just going to choose some random points. There, and there. Let's say that this is the x-coordinate A, this is the x-coordinate B, this is the x-coordinate C and D. I want for each of these times to analyze what's happening with the velocity and acceleration. And again, this is the graph of velocity, which means acceleration is going to be what? I mean, velocity is just height. So acceleration is going to be, yes, you're right, you should be thinking slope. So let's write that down too. So VT, velocity, that's going to be height, and then acceleration, A of t, that's going to be slope. Alright, so this intersects right there, and maybe it's a little bit hard to see. Maybe I can do yellow so it sticks out more. Yeah, that's a little bit easier to see. Right there, there, and there. What's happening at each of these points? And I really care about, are you speeding up or are you slowing down? And these t values, we're going to look at A, B, C, and D. Alright, so what is the velocity at point A? Is it 0, bigger than 0, or less than 0? You have those three options. And you're correct, it is bigger than 0. It's positive, and if you don't like bigger than 0 and you want to just say positive in your notes because that makes more sense to you, you can do that. I prefer greater than 0, it's the more mathematical notation. Alright, so the velocity is greater than 0. What about the acceleration? Again, acceleration is slope. So slope is, well, if I graph the tangent line at A, you can see that the slope here is positive, so this one is also going to be greater than 0. Let's go ahead and just do this whole table, and then we can come back and talk about if you're speeding up or slowing down. So what's the velocity of B? Velocity of B is, yep, it's positive again because the height is above the t-axis or the x-axis, whatever you want to call this thing. You're up here, you're positive. C is negative, so we can say C is negative, it's less than 0, and D happens to be equal to 0, it's exactly equal to 0. Okay, let's go back through and find the accelerations. So the slope here is negative, so it's less than 0, less than 0. The slope here also happens to be negative, it's less than 0. And the slope here, I mean, technically this is an endpoint, but pretend that the graph continues on. The slope here would have been greater than 0. Okay, now that we have our table filled out, we need to come back and ask ourselves a question. At each of these points, are you speeding up or are you slowing down? So let's look at A. A, you have a positive velocity, and you have a positive acceleration. So what are you doing? And if you want time to think, you should pause the video now before I give you the answer. You should really be thinking deep about these questions. All right, so you have an answer either by pausing the video or whatever. The answer is you're speeding up here. If I have positive velocity and I have a positive acceleration, that means I'm going faster and faster and faster. I'm speeding up here. So I'm going to say, how am I going to say this? Let's do a black arrow. I'm saying I'm speeding up. All right, at point B, I have positive velocity here, but my acceleration is negative. So again, think about if you're speeding up or slowing down, pause the video if need be. All right, so the answer here is you're slowing down. At this point, you're slowing down because while you still have positive velocity, you're now starting to head towards not having any velocity. It's as if you, at this point right here, you're starting to throw on the brakes of your car or something. So you're still moving forward, but not as fast anymore. Your acceleration is negative. All right, what's happening at point C? Again, pause the video if you need to. All right, well now you're actually speeding up again. Even though you're speeding up, you're going backwards. So think about like putting your car in reverse and then stepping on the accelerator or stepping on the gas. You're going backwards, but you're going backwards faster and faster because acceleration is negative. All right, and then point D, what's happening? Speeding up or slowing down? Again, pause the video if you need to. All right, this one, you can't really tell. So you It's kind of an ambiguous, it's kind of a philosophical question, but you don't really know. This one is kind of a question mark. It depends on your philosophy, and in calculus, this is also still philosophical. There's not a strict answer. Let's come down here to our definitions to figure out why there's not a strict answer and why these were accelerating, or why these were speeding up or slowing down. So, what is speed? Speed actually is the absolute velocity, or absolute value of velocity. So, absolute value of v of t. So, I still have a lot of speed here. It just happens to be in the negative direction. But this speed and this speed are the same, just in different directions. Absolute value will make sure that you always have the positive value. Makes sense. All right. Speed is increasing when, okay, did you find the pattern in the table? This one was speeding up. This one was not speeding up. It was slowing down. This one was speeding up. Speeding up. I don't know what happened there. Got some lag. This one was speeding up, and this one we didn't really know. Did you see the pattern? And if you don't, pause it. Try to think about it. All right. Speed is increasing when v and t, or v and a have same sign. And speed is decreasing when v and a have different signs. For example, this one was positive and positive, so it's speeding up. This one was positive and negative, so they're opposing each other, which means you're decreasing in speed. Cool. So far so good. Let's go ahead and talk about total distance traveled in terms of position change versus distance traveled. So position change is something that we already know. Let's go ahead and make up some values in here. Let's just say the area under here is 8. I drew a line right here really quick. The area under here is -7, and the area under here is, it looks about the same, let's just call it 8. So just from yesterday, position change means that, say I started, let's just make up a number, let's say I started at position 1 at time equals 0. That means at time equals 1, I'm 8 more to the right, I guess, in this case, if I'm going to the right. So let's say that this is going to be time equals 1. I'm now at position 9. 9, there. All right. And then according to our old information from yesterday, position change now is going to go backwards -7. So we're going to go back 7. We're going to go right here at 2, definitely not drawn to scale, and that's going to be at t equals 2. So in terms of position, you can go backwards, but in terms of distance traveled, it doesn't really matter if I'm going forward or backward. It's just trying to keep track of all the distance that I've gone. So I'm actually all the way over here at, I'm going to say right about here at 16 at t equals 2, if I'm just talking about distance. So this is distance. Distance, can't really spell, and this is position. There's the key difference. You're going forward with distance no matter where you move, because it's just keeping track, whereas position, you can actually go forward and backwards. And that means you could actually have a position change of 0 by the end of the interval. Not in this case, but distance, as long as you're moving, this will never go back to 0. It'll just keep count. So how do we represent that with the integral? Total position change, we know that that's the integral from a to b. Let's actually do this one. So it's going to be the integral from 0 to 4, in this case, 0 to 4 of this velocity function, so of vt dt. And we know how to do that, guy. It's just you add all these up. So it's going to be 8 minus 7 plus 8. And that's going to be 8 minus 7 is 1, plus 8 is 9. Okay, total distance traveled in this case, though, that's going to be the integral between 0 and 4 of velocity of t dt. But now I don't care about if it's negative. I'm going to make sure that everything is positive. It's going to be 8 plus 7 plus 8. The way that I say that is the absolute value of velocity, just as I talked about up here with speed as being the absolute value of velocity as well. The integral of absolute velocity is going to be the total distance traveled. You can see the relationship. In fact, you can actually graph this too, and on the graph, if you graph the absolute value of it, this bump will be on the top and the bump on the bottom will no longer exist. I can show you how to graph that in class whenever I'm there next, probably tomorrow, if you want me to. So what is that going to look like? That's going to be 8 plus 7 plus 8. 8 plus 7 is 15, so that's going to be 23. So I've traveled a total distance of 23, although my position change is only changed by 9. Alright, so that concludes the notes. Go ahead and write your summaries now, and you can begin on the homework. I'll see you guys tomorrow on Friday.